Morning everyone. So recall that in the last class we were discussing first order ordinary differential equation and we studied two methods. One is variable separable or the equations which are variable separable differential equations or equations which are reducible to variable separable form. Yes. So let's see the following problem. Y dash is equal to x plus y by x minus y and we need to solve it. The question comes, is it reducible to variable separable? If yes, then how? Okay, so this equation can be written as y dash is equal to 1 plus y by x and 1 minus y by x, and then I can put y by x is equal to v or y is equal to vx. Why the substitution work, we will discuss it later, but let's first try to solve it. So therefore y dash or y is equal to vx, which means y dash is equal to v plus x v dash, which is equal to 1 plus v by 1 minus v. So I can solve it further and this gives me x v dash is equal to 1 plus v by 1 minus v minus v, which is 1 plus v square by 1 minus v. Yes, if you solve it further, then this gives you dv. Now it is variable separable form, so dv 1 minus v by 1 plus v square is equal to dx by x, and now it can be easily solved considering dv by 1 plus v square minus v dv by 1 plus v square dx by x. Now we can integrate on both the sides, so dv by 1 plus v square, it becomes tan inverse v minus, for this one you should take 1 plus v square as some other variable t, that gives you 2v dv is equal to dt, and therefore this becomes, minus sign would remain as it is, and v dv is 1 by 2 dt, so 1 by 2, and dt by t, which is log t, so log 1 plus v square is equal to log x plus c. And now substituting the required values, it becomes tan inverse y by x minus 1 by 2 log 1 plus y square by x square is equal to log x plus c. This can be further simplified, we are not going to that detail. The important observation is that under what condition we can use the substitution y is equal to vx. This is what we need to study. So to study it, we introduce the concept of homogeneous differential equation, or better to recall it as homogeneous first order differential equation. So to understand homogeneous differential equation, first we know what is homogeneous function. So a function h of x comma y is homogeneous of degree n if we have h of tx comma ty can be written as t raised to the power n h of x comma y. Let me give you an example. So if I consider h of x comma y is x square plus y square, and now if I replace x by tx, y by ty, then h of tx ty becomes t square h of x comma y, which means that the function x square plus xy is a homogeneous function of degree 2. So now a differential equation of the form m dx plus n dy is equal to 0, where both m and n are function of x comma y, is homogeneous if both m and n are homogeneous functions of same degree. So m and n must be homogeneous and their degree must be same. Now recall the same problem, y dash is equal to x plus y by x minus y. So first let's check, is it homogeneous? So if you write it in the form of m dx plus n dy is equal to 0, it looks like this one. Now it's very easy to verify both m and n are homogeneous functions of degree 1. So they are of the same degree, they are homogeneous, and therefore the given differential equation is homogeneous. Now the next question comes, if it is homogeneous, then how to solve it? Why can we use this substitution y is equal to vx? So if the given differential equation is homogeneous, which means m dx plus n dy is equal to 0, which means y dash is equal to minus m and n, where m and n both are homogeneous function of same degree, I can write it as f of x comma y. So where f of x comma y is a homogeneous function of degree 0, because let's say m is a homogeneous function of degree 2, n is a homogeneous function of degree 2, t square would cancel out and they becomes the homogeneous function of degree 0. Now f is a homogeneous function and y dash is equal to f of x comma y. So now y dash can be written as, or you can say that f of tx comma ty is equal to t raised to the power 0 f of x comma y, because f is a homogeneous function of degree 0. And now this can be written as f of 1 comma y by x. Simply this is what we did, because they are of m and n, both are homogeneous. So you can easily divide it by, in case x or x square or something like this, so that it becomes the function of y by x. The same thing we did when we solved the differential equation. So if you see this one, then there I wrote it as 1 plus y by x, 1 minus y by x. Now since I can write it like this, so therefore if I substitute y is equal to vx, where v is a function of x, v is not a constant, remember it, then y dash becomes v plus x v dash is equal to f of x comma y, which is nothing but f of 1 comma v, which is a function of v. And this is because it can easily get reduced to variable separable form, and then integrating on both the sides gives us the required result. Yes, let's try to solve this question. X cos y by x, y dx plus x dy is equal to y sin y by x, x dy minus y dx. Now if you see this question, here it is not required to see it is homogeneous or not, and even you cannot verify it because cos and sine functions are involved, but it is very easy to see that you can only solve it by substituting y by x is equal to v. So here it's a direct substitution. So the given equation is dy by dx. Please do try to simplify it by yourself. It becomes y by x cos y by x plus y square by x square sin y by x, and y by x sin y by x minus cos y by x. It means it is a special case or direct case of the equation reducible to variable separable by substituting y is equal to vx, which is same as y dash is equal to v plus x v dash, which is equal to v cos v plus v square sin v divided by v sin v minus cos v. Yes, now clearly it is a variable separable case, so I can take v on that side. So x v dash is equal to v cos v plus v square sin v divided by v sin v minus cos v minus v. Please do simplify it. Try to solve all the questions by yourself first. If you get stuck, then only please look at the answer. Now because of the variable separable form, this becomes v sin v minus cos v by 2v cos v dv is equal to dx by x. So now the first term becomes 1 by 2 10v, the other term becomes minus 1 by 2v. We know that their integration. So to integrate sin v by cos v, consider cos v as t. That gives you sin v dv is equal to dt. So therefore the first term becomes minus log cos v. The second term is itself minus 1 by 2v. It's not v by 2 but minus 1 by 2v. So this becomes minus log v. I am taking 2 on that side, that's why 2 is not reflecting here, and 2 log x plus log c. Just to write it in a more simplified form, I wrote it log c. If you leave it here also, it's absolutely correct. So this becomes log of sec v is equal to log of c x square v, and that gives you sec y by x is equal to cxy. So please do practice it by yourself, because both the things are important to identify how you are going to solve the question, which method you have to use, at the same time how you are going to solve it. Yes. Now let's move to the next question. It says that x plus y dx minus dy is equal to dx plus dy. So the first step is that, is it a homogeneous differential equation? If yes, then we know how to solve it. If it is not, then how to solve it. So first try to simplify it and see, write it in the form of m dx plus n dy. So if you simplify it, it looks like x plus y minus 1 dx is equal to x plus y plus 1 dy. Now you can easily observe it that it is not homogeneous because of this plus 1 and minus 1. So here h of tx comma ty does not becomes t raised to the power n h of x comma y, and what we have given is dy by dx is equal to x plus y minus 1 and x plus y plus 1. Now think that, can you reduce into variable separable, because this is the only method which you have studied. And yes, it can be reduced, which is directly visible by taking x plus y as some variable t. So take x plus y is equal to t, that gives you 1 plus y dash is equal to t dash. So solving it, so y dash is t dash minus 1, so t dash minus 1 is t minus 1 by t plus 1, that gives you t dash is equal to 2t by t plus 1. Now it is clearly variable separable form, so you can easily solve it. So this becomes 2 dx is equal to 1 plus t by t dt, which is 1 by t dt plus dt. Integrating on both the sides, you will get 2x plus c is equal to log t plus t, where t is equal to x plus y. Yes, so very simple, but you need to identify it is not the case of the homogeneous. If we see one more question, which is y dash is equal to x plus y plus 4 and x minus y minus 6, again you can see that it is not a homogeneous differential equation, and by looking at it, it cannot be reduced to variable separable form because there is no direct substitution which is visible here. In the denominator, if it is x plus y, then you can substitute x plus y is equal to t. So now this is a special case which can be reduced to homogeneous differential equation. Why is it so? That we will discuss later, but the substitution which works is x is equal to capital X plus h and small y is equal to capital Y plus k. Now think over it, that why this substitution or how this substitution will reduce the given differential equation into homogeneous differential equation. Because if you substitute it, then you will get capital Y dash is equal to capital X plus capital Y plus H plus K plus 4 and divided by capital X minus Y plus H minus K minus 6. So how do you reduce it to homogeneous? The hint is very clear, because for the homogeneous you simply want, in the numerator you want x plus y, in the denominator you want x minus y. It means you must take x plus k plus 4 is equal to 0, or h minus k minus 6 is equal to 0. And if you take it, then this gives you the values of h and k, which are unknown to us. So for h is equal to 1 and k is equal to minus 5, you can say that the given differential equation becomes x plus y by x minus y. Now substituting y is equal to vx, you will get dy by dx is equal to v plus x dv by dx, and which is equal to 1 plus v by 1 minus v. Yes, now solving it further, we have already solved this kind of the equations. We will take v on that side, so x v dash becomes 1 plus v square by 1 minus v, or you can say that variable separable 1 minus v by 1 plus v square dv is equal to dx by x. Again you can separate both the terms which are on the left hand side and solve it further. So if you do it, then this becomes 1 by 1 plus v square dv minus v 1 plus v square dv is equal to dx by x. So first term is tan inverse v if you integrate both the sides. For the second term, recall that you must substitute 1 plus v square is equal to t, that gives you 2v dv is equal to dt, or v dv is equal to 1 by 2 dt. So this becomes the integration of 1 by 2 t dt, that gives you minus 1 by 2 and log t, and the right hand side is log x plus c. Substituting the values of v, which is capital Y by x, and substituting the value of capital Y by x, which means v is equal to small y plus 5 and capital X is small x minus 1. So this gives you the required answer. So now the important observation is that if you have the differential equation of the form ax plus by plus c divided by px plus qy plus r, then there are two cases. The first case is when a by p is equal to b by q is equal to some constant. Similarly, we have seen, like if y dash is equal to x plus y plus 1 divided by 2x plus 2y minus 3, you simply substitute x plus y is equal to t, and that gives you the required answer. It reduces into variable separable form. But the next case is when a by p is not equal to b by q, which is x plus y plus 1 divided by x minus y minus 1. In that case, you need to substitute small x is equal to capital X plus h, small y is equal to capital Y plus k, and then you have to assume ah plus bk plus c is equal to 0, ph plus qk plus r is equal to 0, as we did in the previous question, to reduce the given equation into homogeneous differential equation and to find the value of h and k. That reduce the equation to homogeneous differential equation, which can be solved easily. Two quick exercises, they are for the homework. I will quickly solve them, but you must try to solve them by yourself. The first one is y dash is equal to x plus y plus 4, x plus y minus 6. So direct substitution, x plus y is equal to v, that is 1 plus y dash is equal to v dash, or v dash minus 1 is v plus 4 by v minus 6, that gives you v dash is equal to 2v minus 2 divided by v minus 6. Please do verify by yourself the calculations. This becomes v minus x by v minus 1 dv is equal to 2x. I can write it as v minus 1 minus 5 by v minus 1 dv is equal to 2, this is 2 dx, or this is simply integration dv minus 5 integration dv by v minus 1 is equal to integration 2 dx. So solving it further gives you v minus 5 log v minus 1 is equal to 2x plus c, where v is equal to x plus y. The next question is homogeneous differential equation, the case of differential equation which is reducible to homogeneous differential equation by substituting small x is equal to capital X plus h, small y is equal to capital Y plus k, and then we have to take k minus h plus 1 is equal to 0, k plus h plus 5 is equal to 0. Solve it by yourself and you will find h is equal to minus 2 and k is equal to minus 3. Moving further, this reduce the given differential equation is y dash is equal to y minus x plus y plus x, and substituting y is equal to vx gives the given differential equation as x v dash is equal to minus 1 plus v square by v plus 1. Using the variable separable, we have dv v plus 1 by 1 plus v square is equal to minus dx by x. We have done this integration many times. So tan inverse v plus 1 by 2 log 1 plus v square is equal to minus log x plus log c. Substituting the required values, we will have the required answer. So last question, very interesting question. It says that by making this substitution, z is equal to y by x raised to the power n, and choosing a convenient value of n, we need to show that the given differential equation can be reduced to variable separable, and then we need to solve it. Yes, so we need to find the value of n for which the given equation can be reduced to variable separable. So it means that to begin with, we must use this substitution which is given. So we have given z is equal to y by x raised to the power n, or y is equal to z x raised to the power n, which means that y dash is z dash x raised to the power n plus z n x raised to the power n minus 1. Now the value of y dash is given. So y dash is 1 minus xy square divided by 2x square y, and this is z dash x raised to the power n plus z n x raised to the power n minus 1. Now we must substitute the value of y, which is z x raised to the power n. So this becomes 1 minus z square x raised to the power 2n plus 1 divided by 2z x raised to the power n plus 2 is equal to z dash x raised to the power n plus 2n x raised to the power, this is not 2n, this is zn. Yes, now we need to simplify it. So z dash x raised to the power n, and I should take it on that side. So this becomes 1 minus z square x raised to the power 2n plus 1 divided by 2z x raised to the power n plus 2 minus n z x raised to the power n minus 1. So if you simplify the left hand side, please do try it by yourself. It becomes 1 minus 2n plus 1 z square x raised to the power 2n plus 1 divided by 2z x raised to the power n plus 2, or I can take x raised to the power minus n on that side. So dz by dx, because dz by dx was multiplied by x raised to the power n here, so I can take x raised to the power on that side, and because of which this becomes 1 minus 2n plus 1 z square x raised to the power 2n plus 1, and the denominator becomes 2z x raised to the power 2n plus 2. Yes, now I have to see that how the right hand side, what value should I choose for n so that it becomes the variable separable form. There can be multiple answers, but the easiest choice is to take 2n plus 1 is equal to 0, which means n is equal to minus half. If you take it like this, then the right hand side becomes 1, because 1 minus 0, and the denominator becomes 2zx. This simply becomes z dz is equal to integration dx by 2x. So if you try to integrate it, then this becomes z square by 2 is equal to 1 by 2 log x plus log c, or z square is equal to log c square x, or you can further write it e raised to the power z square is c1x, or e raised to the power z square is actually xy square. So this becomes c1x, which is the required answer. Okay, so that's all from today's class. In the next class again we'll see some more cases related to first order differential equation. Thank you very much.